All right, we're going to finish up Unit 3, Section 3 notes. We're going to focus on Earth's oceans. Okay, we divide the Earth into several oceans here you're aware of. The Pacific Ocean, the Atlantic Ocean, you've got the Indian Ocean, Arctic Ocean. You also have the Southern Ocean, right? Newer one named here. The funny thing is, guys, there's actually no barriers between all these oceans. They all commingle into one of them. So we also call it the world ocean. Okay, it's one large interconnected body of water. There's really not smaller oceans out there. Okay, we know this already. Those oceans cover 70% of the Earth's surface. Well, our range is 70 to 76, I believe, depending on what publication you're using. Okay, but these oceans contain how much of the Earth's water? That's right, 97% already. Okay. So what makes ocean water different from fresh water? Well, it's the amount of salt that's in it. Okay. So ocean water contains a lot of salt. It's most of this salt comes from rocks on land, and the salt's carried by liquid water down into the ocean. And then the water evaporates and leaves that salt behind. And so that's why the water in the ocean is a lot saltier than other areas. It's actually the same reason that the Great Salt Lake is salty, right? All that water, rocks that carry that salt down into the water evaporates. And it really has nowhere to go. So it's much saltier than the ocean water, okay? The measure of the amount of salt in water is called salinity. That's what we call to measure it. So it's measure the amount of dissolved salt in water. Now, water doesn't just come from rocks. It can also come from volcanoes, from organisms themselves. But most of the salt is sodium chloride, what we call, that's our basic table salt. So in your ocean water, besides H2O, you have a lot of chlorine and sodium. Chlorine forms salt with some other potassium and calcium and stuff, so you'll see a lot of chlorine in there, right there. Now, the salinity of the ocean water does change depending on the location of the area. So some areas have higher salinity than others. That's going to be important because not all organisms can live in very salty water, and actually not all organisms can live in very fresh water. We're going to talk about something called a estuary. That's where rivers meet oceans. So you have salt water and fresh water mixing. It's what we call brackish water. Brackish water has a mid salinity there. Okay, so it's not very saltier than fresh water, but not as salty as seawater. So that's going to determine a lot of information for you. It also has a lot to do with buoyancy, with density of the water. It's going to be more dense, and that's going to come into play when we talk about the currents. Okay, the currents are going to depend not only on salt but also temperature. We divide our ocean into several layers. Okay, the first one is the surface zone. You have a blank there. The surface zone is warm. It's the top layer. What I want you to write down is that it's warmed by the sun. Okay. So next to surface zone, you notice put warmed by the sun. Now the thermocline, that's your middle layer. It's called the thermocline because you can see the temperature changes drastically in that. Cline meaning change in, so thermocline, change in temperature. Okay. The deep zone is on the bottom. You have a blank there. You can see the temperature is going to be 2 degrees Celsius. This deep zone can be just above freezing. It's not very warm. That's going to come into play as we talk about the ocean currents. Okay, so very deep, it's very cold, a lot of pressure down there too. Not a place where a lot of organisms can survive. Okay. Actually, let's talk a little bit more about that temperature. That's going to have to do with our currents. Okay, the warmer water is going to be less dense. Things expand, they fill out, so they're going to sit on top of that layer. That's one of the reasons they're on the top. While the colder stuff, let me go back down here. This is going to be on top because it's less dense. Let's write that down, less dense. Okay. And then this guy down here, we're going to have more dense. Okay. So we have the colder water sinking, and we'll do an activity with that together in class. Okay. Again, this temperature comes into play because of water have a very special quality, something called high specific heat, and you're going to do a lab on that. But it can absorb a lot of heat, and that's good because actually that allows our oceans to act as a thermostat. Okay. One of the most important functions of the ocean is to store and absorb energy from the sun. Okay? It absorbs over half of the solar radiation that makes it to the surface. This means that a lot of our heat is absorbed and we get to hold on to it. Okay? It absorbs the heat. It keeps it from getting too hot in our equator. And it holds on to it. And actually, because it's really good, it holds a lot of heat. It releases that heat slowly. So you have the energy, releases the energy more slowly than land, helping to regulate the atmosphere. So it can actually hold on to the heat and transfer that heat to colder regions, where if we didn't have that heat from the water, it'd actually be too extreme for life. So this is sort of a picture of what it would look like without our oceans, but since we have our oceans, we get to do a lot of cool things, and that has to do with the currents. I'm going to go ahead and escape out of here for a second. Let's go back to this guy. I'm going to go to ocean currents. Okay. And I want you to notice here. Blue is cold. Red is warm. Okay. And I want you to notice that we have areas in our ocean that are warmer than others. And where do you see most of those warm areas? Right there at the equator. Okay. And that's going to show us some really cool things that's happening. These ripples and things you see here are currents in the ocean. And yes, if you take a look down by Australia, you have the East Australian Current. It does exist. Okay. Nemo wasn't making it up. Okay. But these currents are very important to making sure that the rest of our globe is cool or warm. So let's talk about what type of currents we have. We have surface currents. Okay. Those are going to be the warm currents. They're going to sit on the top of the ocean. These are mostly driven by wind. Okay. And that should disappear, but it's not. So, driven by wind. Maybe cold or warm water, but they're pushed by the wind over there. Okay. The deep currents, on the other hand, those are going to be cold water. Again, because cold water is going to sink. It's going to be more dense. It's going to go to the bottom. Put it there. Deep currents move more slowly across the ocean floor, and they form when cold water sinks at the poles and then moves towards the equator. Now, this water may take hundreds of years to travel from the poles to the equator, but it eventually will get there. That cold water will come and help keep this area cooler, and the warm water from this area will keep the cooler areas warmer. Okay. And again, we're going to talk about this more when we talk about climate, but I do want to talk about something called the Gulf Stream. You can see it right here on our paper. Here we have the Gulf of Mexico. We have some warm water coming out of the Gulf of Mexico and moving up along the east coast. And notice where it is. Here we have the Carolinas. It's still pretty warm along the water in the Carolinas. We like it like that, but it's when you get cold, when you get a little further north into Virginia and stuff, it's not as warm. It's because one of the reasons is because that warm water is actually starting to move away, and it moves actually across the Atlantic Ocean. Okay, and it's sort of heading towards Great Britain over here. Now look and see how much farther north. Here we are in Ohio. Here's Great Britain over here. It's much farther north than we are, okay? But it's actually a little bit milder in temperature. Here you have a picture of Cotswold, England, okay? Cornwall, England, sorry. Cornwall is on the southern coast of England. And actually, you can see that it has palm trees growing there. Even though they're so much farther north than us, what's happening is all that warm water is being taken over to the southern coast of England, and it's making the southern coast of England pretty warm. It hardly ever snows there, if at all. Just like it's sort of like Florida, okay? It's warm enough that you have mild temperatures, mild climate, and that's one of the really great things that oceans do for us. So we're going to spend some more time on that later this year, okay? So if you have any questions, let me know. Right now, you should be working using this information to help you out with your How Cool is Water activity, okay? As well as some other activities that we'll do in class together. All right, so have a great afternoon, and we'll talk to you soon.